Let's review what, well, actually, we don't even, technically, this assignment doesn't even require Firebase, right? We just change the way our local objects are interfacing with Firebase for storing stuff. So we saw that it is storing on Firebase, but we're not actually reading from Firebase yet. So up here in main activity, we are calling build dungeon. So build dungeon is building a couple of rooms. It's then creating the dungeon, passing it the main room, CS hallway. Then we're adding this other room to the array list in dungeon. So dungeon, we now have a array list of exits. I'm sorry, array list of rooms in there called rooms. And when we first build a dungeon, we give that guy a value. So we have an empty array list. Then we add the start room to it in the constructor. And similarly, add room adds additional rooms to it. So bucket 0 of that array list would be our start room. Bucket 1 would be our S120 from adding there. All right, then we build an exit that links those two rooms, but instead of linking the room objects, we're linking the room at bucket 0 with the room at bucket 1. So we're actually storing the indexes of the rooms that exit links. Does that make sense? So this exit links to bucket 0 and bucket 1 from our dungeon's rooms array. All right, and technically our dungeon's rooms array is public. We made it public so that it could write to Firebase. All right, then we added that exit. Here's the writing stuff to Firebase. So for right now, let's just take that out. We'll add the Firebase stuff today so we can read from it as well. And then see that we can change it in Firebase, rerun our app. Actually, we wouldn't even have to rerun our app, and our dungeon would update. Okay, so we already have a button in our interface when we click an exit button. All right, so when we click an exit button, we go ahead and grab the button. Then we ask, well, this is where we try to take that exit. So this p.getCurrentRoom.take exit. So this is a room's take exit. And the exit we're going to take has to do with the text from the button to lowercase. Let's also make sure that our fill interface is doing what it needs to do. Let's just run this real quick. Okay, so we're not getting our exits processed yet, so we need to do that. So when we add an exit to CS hallway, we're also storing our exits in our dungeon, but we're not actually using that yet. I think that's going to be okay. We are not adding the player to that current room. So we need to go ahead and throw the player into the room. So that's this add player. So we'll go ahead and throw the player. So this CS hallway dot add player, this dot. This the player. What did I name him? Oh, this dot p. All right, so that'll add the player to the room. So when we fill the interface, we're going to go through and this is the code we commented out last time. Is there a quick way to undo these comments? Control Shift slash?
With no shift.
Or just Control. I gotta undo what I just did. So Control / Command / probably on a Mac. Okay. All right. So we have our room. And we got rid of get players. We don't need get players anymore because get players, we could still have it, but this guy might not be a linked list long term, but we'll leave it as a linked list right now. It's not going to hurt anything because we're not actually storing players. We're storing the dungeon structure state in Firebase, not the dungeon's current state as far as players and NPCs and those things go. No, it'll store it as an array list.
Okay.
But we're not actually storing these in Firebase at this point. So we could change these to array lists right now if we wanted to. I mean, we could even go ahead and do that. It's not going to hurt anything in case we decide to store it in there. But this wouldn't have made any difference on the homework. All right, so that guy will be an array list. We'll go ahead and give ourselves our convenience functions back, but they're technically not needed because the things here are public. But I think it does look a little bit more formal. And right now our exits are actually a map. Okay, but they were public, so we didn't even need these guys. So now when we're going to be rewriting take exit here in a second. So our button shouldn't work for the moment. But back here in main activity, we can now go through and get all the players that are in a room. All the NPCs that are in a room should now also work, even though there's nothing in there. We can hide all the buttons initially. And then we can go through and show the exits again. All right, so from CS hallway, we now have an exit to the south. From S120, presuming we can head to the south, we would have an exit to the north. The issue right now is when we try to go south, it wants to call the take exit function. So if we go to main activity, is my button click down here? On exit button, we're going to grab the button. Then we're going to get the current room the player's in. So that's the room that they're doing this for. We're going to try to take an exit, which we currently have commented out, which is why this guy's red. And the exit we're going to try to take is in the direction of whatever the text that's on our button is. All right, so same thing as before. We just need to go and update take exit to correctly take us to the new place. All right, so let's go into room. And let's go ahead and uncomment take exit. So we're going to go in a direction. Okay, so now we need to go ahead and get that exit associated with the direction locally. So that's all fine and good. That works. But remember, the nature of our exits have now changed. Instead of us having two rooms in here, we actually have the index of the two exits. Make sense? All right, so now we're asking the question, as long as we got a real exit from that, we're trying to take the exit from the players get first. We were doing this because that was the only player that we currently have in our players array list now, right? All right, so since we made an array list, we'll say get 0. Get first wasn't a function of array lists. It was a function of linked lists. Okay, so we're going to have our exit attempt to take an exit given the player. So now we go into exit, and this is where we're trying to take that exit. All right, so before we had a room called R1 and a room called R2. We no longer have those. Now we have a room index for R1 and a room index for R2. So I'm going to go ahead and let's set room R1 to something and room R2 to something. Room R1 should be the value from this particular, let's see where we at, our dungeons rooms array at bucket R1 index. Room number 2 should be our dungeons rooms array at bucket R2 index. Those are the two rooms, right? So from in here, I need to have access to my dungeon. How do I give myself access to my dungeon from within the exit class? Say this again. I don't want my exit to be a dungeon. I want my exit to actually have access to, where are we at here? To this guy. Where am I setting my dungeon? Yeah, but am I actually building my... Yeah, where am I building CS department? Oh, I'm probably building it up here at the top. Well, here's CS department. I'm adding a player to this guy right here. Oh, right here. This .cs department is equal to a new dungeon, CS department, and here's the default room. So how do I allow all of my exits to have access to this variable? Because that's the variable that actually holds my collection of rooms that I have indexes for, correct? So how do I make that variable available to this class? Who? It's is it already public? If it's not already public, I'll go ahead and make it public, and then you have to help me do it. All right, there you go. It's public now.
Main activity, you call main activity. Oh, you can just import the main activity.
Import main activity?
It's already in the package.
Well, main activity, though, this is a class. Yeah. I need this particular instance of this guy in order to get one of his public members, right? Yeah. So we have the same problem. So we can either say, how do I get access to this object, this instance of an object inside of exit. Or if you want to go your route, how do I get access to the instance of main activity from within inside exit? We have all the tools in our repertoire to do this.
You just call
If I called main activity dot, what would CS department need to be? It already is a field. It would need to be static. It would have to be owned by the class in order for me to get to it by main activity dot. But he's not static. Just make him static. Okay. There's a substantially easier solution to this. It actually surprises me that everybody's missing. Okay. So here, I'll make this private again. Still not what I'm thinking about, but I'll play the game. So where do you want me to add you want to add a field here to the exit class?
Yeah.
So public dungeon, the dungeon, something like that.
And then you would add it into the constructor, but unfortunately, because dungeon has a field that's defined in terms of exits.
We'd have that infinite loop problem again.
Exactly.
Okay. So this is a no-go?
Can we just send it as a parameter in the function?
That's what he wants to do.
And
Oh, you mean instead of having exit know about the dungeon, you want take exit to take in a dungeon D, like that. And then the guy who calls take exit would be room. So that means when we try to take an exit for a room, he would also need to have a dungeon passed in so that he had something to pass on. And then back here in main activity, when we hit the, when we try to take exit, we would have to give it this dot CS department like that. So just pass it through. So when we try to take the exit for main activity, hand it the CS department to room. Then room hands the CS department to the exit. The exit then uses the CS department. Oh, this guy requires 2 parameters, so I need to pass it the dungeon. Okay, because now I'm taking an exit. Exit now takes a dungeon as a parameter. And then over here in exit, we're going to say room 2 is equal to d dot rooms dot get this dot r1 index, and r2 is equal to d dot rooms dot get this dot r2 index. Okay, so now I can just remove the this dot from these guys because they're local variables r1 and r2. Use the same logic I had before, but what I had to first do is I had to go ahead and find my rooms by looking them up in the dungeon's rooms array index, or rooms array list. So now I should be able to run this. Let me make sure I added the player to the room because I have a feeling this guy didn't actually get in the room. Players. Yeah. Remember we commented this out last time to get our errors to go away. So we never actually added the player into this room. Therefore, get bucket 0 wasn't getting me anything because players array list was empty. Yeah, we do. That'll crash later on in the process. So now we have to go down and give ourselves the ability to actually remove a player from the room now. So now he can go south. Now he can go north. So there is a solution to the homework. I don't really like this solution, but it works. This is okay. I think this group can do better. It really, all of you are going to be upset when you remember how easy this is actually to do. It must be something you've just not used too recently, although you've used it somewhat recently, that you've forgotten about it. Yeah. A singleton! So we're going to create a variable, maybe an object called core, throw the dungeon up there, and then we can get to it from wherever. So we'll go ahead and we'll create a new Java class. We've traditionally called this guy core. Inside here, we'll have a public static dungeon. And we can call this the dungeon. So this will be whatever the current dungeon is. And then inside of main activity, after we've created the dungeon, we can say core.thedungeon is equal to this.cs department, because that is our actual dungeon. Go into room. Let's remove our dungeon parameter from take exit. No longer need this because we can access it through the singleton. We're going to be removing our dungeon parameter from exit, so we won't pass it there either. So now our take exit for exit also does not require a dungeon. So instead of D, we'll say core.thedungeon. We can extract our rooms that way. We should still have one error in main activity because we're now passing it the dungeon. We no longer need to pass it that parameter. And I think that should do it. All right, so that's using our singleton to accomplish allowing an object to be accessible across multiple classes. Make sense? So why did we forget about singletons? What happened? Huh? You never used them? Well, why? Doesn't it seem to be a pretty good solution to this? Because you're pretty lucky that you only had 2 layers to have to go through. Otherwise, if you had like 15 objects deep, you would have been passing dungeon to dungeon to dungeon to dungeon till it finally got exposed to the guy down at the very bottom of the heap that needed it. Right? So do we think that we might need access to our dungeon from various points in our program? Yeah, I mean, that seems to the way we have dungeon written right now, where we have this collection of exits and a collection of rooms. Every exit is going to need to know about this guy. Now, that doesn't mean that your solution was wrong. It worked. We only had to pass it 2 levels. Not the end of the world. Okay? But we did create some coupling there, right? Yeah, so we've all of a sudden made this function reliant on the existence of a dungeon and this function reliant on the existence of a dungeon. So now those 3 classes can only exist together. But that's okay, because they do exist together in this particular project. And they're not necessarily generic type objects. But certainly from a convenience perspective, throwing this guy up here in core, I mean, this isn't a whole lot of code, right? Made it pretty easy to give ourselves access to those variables. So don't forget about singletons. Very, very, very important. But also very easy to overuse. Okay, so what's that thing? With great power comes great responsibility. Because as a programmer, you might throw everything into a singleton and just say, I don't even need to pass parameters anymore. Okay, I'm just going to toss everything up there and make it publicly available to everybody. Okay? Now, if you don't need it, don't use it. Now, that would be bad programming practice, right? So a good rule of thumb might be that if only a single object needed access to something, go ahead and pass it to that object directly. You could maybe even make the argument that if two objects needed access to something, you could pass it to those two objects directly, rather than muddy up your singleton. But if you need access to something from many parts of your application, and you perceive in the future you're going to need access to something from all over the place, it would make more sense to give yourself public access to it through a singleton than it would be to kind of snake it through the pipes all through your application. That makes sense? And it's kind of the reason why we have Wi-Fi in our houses instead of running Ethernet cables after your house is already built most of the time. Make sense? Because it's easier to have a singleton and to run Ethernet through your walls. That's actually a really good analogy. I like that one. That's a good idea. I like the way you think.
Storage space is scarce, isn't it? Many of our storage space with yet more classes.
Well, this is actually better. This is actually better. Because this is one class that you're not even creating instances of. As opposed to passing, the footprint of your functions will be significantly larger than having one class you're not creating instances of. Yeah, so this is still better than, this is more like recycling. This is better for the planet. Better for your systems resources. All right, questions about that? So a couple different ways to pull off the assignment. Not too bad after we saw it. Significantly worse when you were trying to do it. Those are my favorite assignments. Where when you see the answer, it's like, oh my gosh, are you serious? Because at the end of the day, after we uncommented our stuff, all we did was that. We had to remove a couple of thises from the front of the R1 and R2 because now they're local variables instead of fields. But those two lines and this class gave us everything we needed. Those are always fun solutions. Okay, so let's see. What comes next in our world now? It would probably make sense for, after we initially create a dungeon, for us to be able to, now I realize right now we're kind of creating our dungeon as part of our game. But, if we think about this down the road, we might kind of have a dungeon creator tool, right? That allows somebody to go through and make a dungeon and ultimately upload it to Firebase. And then what we do is we give the name of the dungeon here that we want to load from Firebase. And it hits Firebase and pulls that dungeon down and builds out all those objects from Firebase. And if we want to make a small change to that dungeon, we can either go back to the original tool, or we can go into Firebase and just change the spelling of something, whatever. And next time we run the program, the dungeon will be fixed. Make sense? All right, so what we want to do now, since we have a dungeon, let's just make sure I only have one dungeon stored in Firebase. It's a real challenge. I have multiple dungeons now. One dungeon, the Npcs department. It has 2 rooms. Okay, that looks pretty good, right? So I'm going to go ahead and comment out my the stuff where I'm writing. Well, I already have it commented. I'm no longer writing to Firebase. Okay, and what I think I should do is actually let's comment out the current build dungeon, and let's write a second build dungeon. And that guy's purpose is to read in from Firebase our dungeon. That way we still have our old code for how we wrote it to Firebase. We won't dump that. We just won't be calling it that way. I don't write a brand new dungeon each time. Yeah.
So can you go back and put your Firebase stuff back in and then
How did this get built?
Yeah.
All right, so let's dump this.
So, okay, start by clicking on Firebase.
This guy. Okay.
And then you click on anything.
All right, so then I clicked on Dungeons and Data Structures. Okay. Then I click on database. Well, it might be under develop. So click on develop. That should open up develop on the left. Okay, so I click database. Now mine looks like this. You might have those two icon things, two things. So if well, I'll get mine into that state. So I'm gonna go ahead and just delete my whatever. All right, and then I'll just go to hosting and I'll click back to database. So your screen looks like that. Okay, so on this right side where it says real-time database, click get started. And then this is the thing where we can choose either locked mode or test mode. Since we're not authenticating, make sure you choose test mode. And that will make your database read and write from everybody. Then click enable. All right, now you should have an empty looking guy here. And then let me go ahead and go back into my code. And then in main activity, let me just uncomment these lines once and rerun this. That way it goes ahead and builds my database again. Oh, it died. Failed binder transaction. Is the internet up? Well, yeah, the internet must be up. We were just clicking on stuff. So let's make sure our program is still linked to Firebase. So I'll go to real-time database, save and retrieve data, connect to Firebase. Resolve Gradle build issues and or resync. Okay. So it wants me to resync Gradle. Easiest thing to do here might be just to quit Android Studio, relaunch Android Studio, which will cause Gradle to resync. Of course, there's an ID and plugin update. I just updated it the other day. So go back to Firebase. Go to real-time database. He leaves class in a few minutes. He's got another class he goes to. All right, so notice it says connected now. So now we're reeling. So I was messing with this the other day, trying to get it hooked to a different Firebase database. I wonder if I messed up Gradle from that. So now we should be able to run this. And hopefully it's a better outcome this time. Oh, same. It's not able to hit the network. That stuff is good. Oh, hold on. I know what the issue is. In our exit, not exit, is it room? When we put back in our array list of players and our array list of NPCs, it no longer can write to the database because I think we have the infinite loop with these guys again? Because a player technically holds a room. Where's my player? And a room technically holds a player. So we have to update player in the same ways we did last time to, a player now needs to know the index of the room in which they live in, as opposed to the actual room. Okay, so we'll go to player. Well, really, any of our characters. A character currently knows about their current room, but we're going to change this to current room underscore index. So that's going to be where that room lives in the core dot the dungeon dot rooms. Make sense? So we'll set this dot current room index. We'll default it to -1, which means we are currently not in a room. No, because we had all that commented out. Yeah. Well, you would only need to have done it for your assignment if you were trying to write to Firebase. If we weren't writing to Firebase, everything would have worked the way it was before. But now that we're writing back, because you just saw it work a few minutes ago, we didn't have to make this change, right? But now that we're trying to write to Firebase, when it tries to write the player object to Firebase, which is now part of, it's currently trying to write players to Firebase, but we don't want it to write players to Firebase. The reason it's writing players to Firebase is inside of room, we now have an array of players. And if we're going to write players to Firebase, a player cannot have a player as an extension of character. It can't have a room object as one of its things because that created that infinite loop that we had last time. Because last time we had rooms have players, players have rooms. So those end up spinning back at each other where a player tries to write a room tries to write a player, so on and so forth. And that's why it's failing out at, but we can fix players and NPCs here through the character class by, instead of storing the actual room they're in, storing the index of where that room could be found in our core.thedungeon.rooms. Okay, so then right here, when we get the current room for a player, it's still going to be a room. How do I get the room that this player is currently in? How do I get the dungeons list of rooms? Core.thedungeon.rooms. And I want to get what index? This dot current room index. That's where that's the room the player's in. So the player is holding on to kind of his hotel room number, right? And then he has to go and actually look up that physical room object through the dungeon. All right. Set current room is going to work differently now. This guy's going to take in a int current room index. And we'll set this dot current room index equal to current room index. So we'll have to tell it the position of that room, which is going to be good for us since we happen to have positions in our exits. So our exit, when we take an exit, that's the guy that removes a player from the room and puts a player into another room, right? So to remove a player from a room, we set his current room equal to -1, and we go to rooms and have to remove that list of that particular player from there. To add him to another room, we add the player to the array list of players in that room, but then we set his room index equal to the room index of the room he was added to. All right, so down here where we try to perform an action, when we are adding a player to a room, we're trying to set that player's current room to this. No longer works that way. Now we need to set this player's room equal to the index of this room in our dungeon. We have how do we get the index of this room in the dungeon's room object? So I'm a room, I'm a physical thing, right? But I happen to know that there's a pointer to me in the dungeon, so core.thedungeon.rooms. How do I find out what my index is up there? Well, if I have a collection of stuff, all right, so I'm telling you to find the ace of spades. I spread out a bunch of cards. What are you going to do to find what position in that deck of cards, 0 through 51, what position in that deck of cards the ace of spades is? You're going to search. Is this it? Is this it? Bucket 3 it, bucket 4 it, bucket 5 it. Ultimately getting, found it here at bucket 17 or something like that. Okay, you mentioned index of. Return the, I don't know if array lists have an index of, we can check. Okay, otherwise we can write our own little index of and find it, right? So we could add that to a dungeon. And now dungeons are able to return an int, find index of room, given a room. So we're looking up the index of a room, right? So given a room object, it wants to find the index of that room. So we're going to say return this dot rooms dot index of R. So that'll return the position in there of that room. So that means every single time we take an index, take an exit, we have to go and look up, do a search for that room. We have to run through the hotel until we find the right room. We might say that's a little inefficient. That make sense? Now, alternatively, every room could store their room index, right? We could decide to store our room index. So we can still give this dungeon this ability to go and look up, find the position of a room inside of our rooms array. When we build a room, we give it a name and a description. Now, a room is built before it's placed into till it's placed into the dungeon, right? So when a room is first built, we don't know what its index is. So what we can do is we can say that a room has a public. This becomes a little dangerous from the perspective of now it's going to store the index of that room in Firebase, and what if the index of the room changes? So if we add another room or something like that. Wouldn't actually be the end of the world. It would still work. It would just kind of look funny in Firebase because you would have this like weird room index thing that says 13, right? Because that just happened to be where the guy was in the database before, the last time you've updated the dungeon. And then if you add some more rooms to the dungeon, it might not be at room 13 anymore. Now it might be room 19. If you remove some rooms, it might be room 11. It would still work because the next time you ran the program, it would read in the new list of rooms. It would update its position, and this guy would update its position But it would help with performance down the line. I think for us right now, it would make more sense logically for us to say when we need a room to know where it's located, it should just ask the dungeon to find it. Technically, it's slower, but then we won't have this extraneous variable that's just holding this weird number. All right? But holding that weird number would actually be faster. So maybe the very first time we try to take an exit, we would try to find, or actually in this case it would be add a player, right? We would find that number because the room would advertise that its index is -1. And if its index is -1, that means it doesn't know where it lives yet. Then we would go ahead and change it to what it currently is so that each next time that room is entered or left, it already knows its position and doesn't have to look it up. But for right now, let's just do the lookup. Okay? So in room, when we're setting the current room for a player, remember a player, which is a character, is now holding a current room index. So we're setting current room, I'm going to change this to current room index here, which will set the index to whatever number I pass in. All right, so a player's current room index is equal to, and I'm inside of a room right now, it's equal to core.thedungeon.find index of room passing himself. This, from inside the room object, is this particular instance of a room. He's going to ask a dungeon, here is me, tell me where I'm located in your rooms array. And he'll spit back an int. That make sense? And we'll go ahead and tell our player that the current room he's in is room number this. Or room number, whatever that guy returns. Go ahead.
So for our singleton, so since we made a dungeon in there, it can use all of the functions that we have in our dungeon.
As long as they're public and they're instance methods. So if we,
Because we named it the same? Or
well, no, so this is a variable. So this guy has a bunch of public functions, right? So if we had an instance of a dungeon, we could call the find index of room. We could call the add exit. We can call the add room. All those functions are accessible provided that we have a instance of dungeon, because these guys are all instance methods.
in our instances, what we have in core.
What did I do? Yeah, so core is expecting me to give this guy an instance. Right now, it's just a variable capable of holding an instance. He actually got his instance here in main activity inside of build dungeon when we set the dungeon equal to the CS department. That's where we shared with core a pointer to the dungeon that we built in here.
And that's what you were saying, with you have to build your dungeon, or build the CS department first.
Yeah, we actually, I mean, in order to set core.thedungeon equal to an instance of a dungeon, you have to have an instance of a dungeon. You can't throw the pot roast in the pot if you haven't gone to the grocery store to buy the pot roast. You got to actually have the real deal first. So this .cs department in here has the exact same memory address as, where's core? Core.thedungeon. They're synonyms for each other because they both point to the same place in memory. All right, so when we add a player, we're going to be setting that player's current room to wherever that room is located in the dungeon. When we remove a player, we're going to set that player's current room index, let's say to -1. He's not going to be in any room at the exact moment, but we're assuming he's going to be placed into another room in a moment, right? So that's equivalent to us setting his room to null like we were doing before. All right. Same thing. We have to do the same thing for NPCs because NPCs and players are kind of the same kind of animal. Actually, they're identical animals for us right now, right? Because they're both characters and we haven't further differentiated those two things. So for an NPC, we will set the current room index for this guy to core dot the dungeon dot find index of room this. Similarly, we're going to remove it. We'll set the index equal to -1. All right, that makes sense? So now we've updated characters to support where they can find their room, not the room itself, which should mean now that characters can get stored inside of our database. Now the reality is we would probably store our room. See, right now inside of our main activity, when we're building our dungeon, we're actually storing the dungeon after we've added the player. So we'll technically get the player's information up there, which is okay. We can go ahead and see that. But if we didn't want players to play a role in our database being stored, we would go ahead and store it prior to players being in there. And that would make sense if we had a separate like dungeon building tool, right? Because, you know, in that case, we're not placing players into the rooms. Having said that, we might want to place NPCs into the rooms. So when we're designing a dungeon, we might decide that, you know, this troll lives in this room or something like that, or Dr. Locklear's in his office. All right, you know, that type of thing. So we would put him in the game as an NPC, right? And then be able to obviously attack. Are any of you looking forward to being able to attack your teachers in this game? We could also put fellow students in here. It doesn't matter. They're not playing the game. They're fair games, so to speak. So start creating your hit list. Digitally only. Let's take out our frustration in a video game, right? There should be a zombie baby somewhere in here. You weren't in that class. I was in the game programming class. We had a zombie baby as our main character in one of the games. All right. But at this point, a player should be able to get written out to Firebase so we'll see what it looks like because it's going to look the same as an NPC would. But right now, our list of NPCs in all the rooms will be empty because we don't actually have NPCs in the rooms. We'll add some NPCs here shortly, but right now we don't have them. Okay? So a player is nothing more than just a character, and a character has a public name, which is a string, and a public current room, which is an int. Make sense? And actually, that current room will start off at -1. But when we added the player to the room, he would have gotten his index, which would be a 0. Okay, so I think character and exit, those look good. Character look good, and which means NPC and player are good. We already knew room was good. A dungeon can store a room. A string, some array lists. We're good there. We don't have to worry about core because core isn't one of our public fields, so it's not going to try to store core in our Firebase, which means we won't have that weird loop thing coming back in for like a dungeon stores, dungeon uses core, which then means that it loops back up and you have a dungeon to core to dungeon to core, dungeon to core over and over again. Shouldn't have that issue. So now let's go ahead and try to write this guy. The same error? Let me make sure I ran it.
Do you have to bring your Firebase stuff in?
Shouldn't have to. All right. I hope it isn't having problems with an abstract class. Because that is possible, that it's having problems with an abstract class. Just for the sake of argument, let's go into player. And instead of player, we'll go ahead and detach player and NPC from the character abstract class. It could be Firebase doesn't like the abstract class dealy. I'll just steal those couple of functions from there. Okay, and we no longer need, we do need the no argument constructor because that's what Firebase needs. Go ahead and copy that for NPC. So NPC no longer extends character. Here's those couple of public fields. Update his constructor for us. And then go ahead and give us our public functions for that guy. So we are duplicating some code to avoid using an abstract class. Which will hopefully fix our problem. It did not. It's a disaster. All right, where have we gone wrong? Exits should be fine. We've written them before. What we haven't written is NPCs and players. A player has a public string, public int. Those are things that are valid to write. NPC has a public string and a public int, also valid to write. Dungeon has a room, we can write those. It has a string, it has some array lists, which we can write. And it's an array list of exits, an array list of rooms, and we've written those before. All that looks good. So what has changed is the nature of our room now, because our room, we've gone ahead and uncommented players and NPCs. And we've made them array lists of players and NPCs. Just out of curiosity here, I should be able to test it this way. Let me not add a player. Well, actually, just so we don't break other things. I'll still add the player to the room, but I'm going to add it after I have written it to the database. This will tell us whether the issue is inside of player or an NPC. Well, player in this case. Okay, it's player. So that guy seems to be happy, which is good because we didn't necessarily decide we wanted to store players. But now we're intrigued enough, we want to know why players are broken. So when I added a player to CS Hallway, which is a room, That's sent. Temp, which is a player, added it to my array list. Now up to this point, we've only stored array lists of, so for our dungeon, oh no, dungeon has an array list of exits and rooms, so we should be able to store array lists of objects. Set the current room index. That should be fine. Because a dungeon knows about a room object, a player knows about the int that represents the room that he's in. Those should not be in conflict. Player looks so benign. There's nothing in there. So the difference between it writing and not writing to the database is whether or not a room has a player in it. And when a room has a player in it, its array list of players has an element in it. Otherwise, here, let's look at our database real quick. Does it store players and NPCs and just have nothing in there? Or does it not store them because there's nothing in there? Yeah, it does not store players and NPCs. It stores exits. So there should be another two things here, players and NPCs that have nothing in it.
I think the NPC forgot to take out a comment in the room.
Oh, I still have something commented in NPCs? Yeah, but this shouldn't be causing a problem because we aren't adding any NPCs. We're only adding, I mean, this is right. This would have made NPCs fail to add an NPC to our room, but this should not change, this shouldn't impact players. Add this player beforehand again. Just in case, I'm going to do a clean on the project and then rerun it. Just in case under the hood, players and NPCs are still linked to character. I mean, this is the exact same output as we had before when we had the infinite loop thing. So somewhere in here, we still have an infinite loop thing associated with a room having a array list of player objects where a player object just stores a string and an int. We know it's storing exits. We know it's storing description. We know it's storing name. We don't see it storing these things. It doesn't have a reason to store NPCs, but the second it tries to store players, it runs into a problem. When we create a room, players is a created array list, nothing in it. You have an idea? No idea.
It's weird that.
It's what?
Weird.
Well, I'm sure it's a.
Understand Firebase.
I'm assuming it's a stupid mistake we've made, but it's not an issue where players have not been instantiated. We definitely have the collection.
Or breakpoint and walk through the code.
Well, it's creating. It creates our player object. If we take the Firebase stuff out, everything works. It just can't write that to Firebase. And there's no place to put a breakpoint because that's going to be inside of Firebase's libraries.
Maybe it doesn't want that kind of object.
But that kind of, I mean, I get what you're saying, but that kind of object isn't any different than a dungeon that has a name and an array list of rooms, where an array list of rooms has an index, and then it has a description, an array list of exits, and a name.
Maybe instead of what is it? Not build, but update the database. Since you already have one built right now.
Or if I deleted it.
Yeah, try to delete it.
I did.
Oh.
It did. That was when it wasn't running the first time. That's when I moved the line inside of main activity after. Yeah, so right now it won't write. The same issue. So it's not writing in there. Can't be player. Can an object not have more than one array list associated with it? Because this guy would have a map, and then it would also have an array list of players and an array list of NPCs. We're not using hash map anymore. Actually, we are using hash map. We're not using hash table or linked list anymore. We're not using enumeration or dictionary. I'm going to have to stare at this some more. So what I'll do is, as an extra credit opportunity, I'll push this. If you figure out what the bug is, I'll give you extra credit. I suspect I'll figure it out later on today, but I won't say anything on...
We have till Tuesday?
Yeah. So if you figure out the bug, private message me rather than putting it out there publicly. That way everybody else has a chance to debug it. I suspect it's going to be something very stupid. It definitely is that, well, I want to say it's definitely that same situation of the infinite loop thing. I'm just not seeing where it is. And while you won't be able to go in and see my Firebase database, you will be able to see that it ran. So if your app launches, that means it wrote it to the database. That make sense? All right. See everybody on Tuesday.